Okay, so now I share the whiteboard. Can you see the whiteboard?
Not yet, uncle. Yes, now I.
Okay, good. Okay, so how are things with you? Like your studies, everything fine?
Yeah, going good, going good.
Yeah, and are you questioning yourself to understand everything?
Yes, yes,
And I mean, not only in maths or physics. I
yeah.
mean, you need to do that for everything you are doing, and everything what you are doing should not only target the right answer. Right answer is available everywhere, but you are learning something. You have to question from that point of view, why I am doing that and what I am learning, whether it is already thing I know, and how the new problem or something what you are doing is helping you to strengthen that understanding. Okay,
Okay,
so the confidence and the courage will get developed very quickly with you. Okay.
okay.
Okay, so you remember the last thing what we discussed in the trigonometry, we derived
Yes,
the
we
sine.
saw how to tell how to find the area of the triangle.
Yeah, okay, that application also we have seen,
Yes,
right?
yes.
So when we see the cosine rule will involve all the we can apply that for the right angle triangle also, but generically when you use it for any triangle with the sides lowercase ABC, that is actually the sides opposite to the angles capital A, capital B, and capital C. Okay, I can even draw the make it life simple. This is our ABC, for example, right? And we normally write the opposite to the angle A, that is the one we call that as a lowercase. So opposite to the
I.
angle C, we call that as a A, and opposite to the angle B, we call that as a B, right? This should be C.
See, yeah.
Okay. So the cosine rule will look like okay. Let me try to write that. So if you take cos A, that would be B square plus C
C
square
square
taken as
minus
B
A.
square, yeah, divided by 2B.
2B.
So the cosine of one of the angles will be given in terms of the other three side lengths.
Okay.
Okay, so this is nothing but actually modified or revised cosine angle ratio trigonometric function, cosine acting on the angle in terms of the three sides of any triangle. You get that?
Yes,
Normally if it is a right angle triangle, we know cosine of an angle is the adjacent side to the hypotenuse.
yes. Adjacent to
Okay.
hypotenuse. Yes.
Yeah, now this is this we can understand something like this is also something like a adjacent side by hypotenuse, but the adjacent side and hypotenuse is not very well defined in a non-right angle triangle.
Okay, yeah.
So this will be a mixture of the the all the three sides. That is what this formula is saying. So we
Yes,
know what is the meaning of this, and also we know how to derive this, prove this. You're okay with that, right?
yes.
And this will be useful in a place where we know the three sides length, and if you are interested to find the three angles, then cos A will look like that, cos B will look like the A square plus C square minus B square over 2AC, and cos C will look like
Yeah.
A square plus B square minus C square by 2AB. Okay,
Yes.
three sides known, then three angles can be calculated. Calcu- Calculated using cosine rule. Okay.
Yes.
So we need to learn things. We need to be confident enough to prove them also, and connect to the previous thing what we have as a knowledge as trigonometric function definition for the right angle triangle and everything. How this got extended here. Even the Pythagoras. Actually, this is an extension of Pythagoras. Lead to the
Okay.
cosine angle for non-right
Yeah.
angle triangle. Okay, and when to apply and everything. So in the same way, Are you okay up to here?
Yes, sir.
Now, if you go for sine rule will look like A over sine capital
Sin
A
A
equals, yeah,
B by sin B equal to C by sin.
yeah, this looks like. So here the statement is, mean again the same non-right angle triangle like this, like let's say A, B, C, then we call that as A, C, B.
B.
Now here this can be actually split into three different equation, because in an equation having two equal symbol is not a good. So sin A equals B by sin B,
Yes, sir.
and A over sin A is actually equal to C over sin C,
Yeah.
and B
And
over
B over sin B is
sin
equal
B
to C over.
equals C over sin C. Okay, so this is
Yeah.
actually, if you see these three of them, they will connect two sides and two angles, right?
Yeah. Okay.
So whenever you have a problem where you need to connect two sides, and if you know two sides and one angle, the third angle can be found out.
Okay.
Or if you know two angles and one side, the other side can be found out.
Okay.
So, I mean, I'm saying indirectly, I mean, this can be written as A over B is actually equal to sin A by
Sin.
sin B. This can be written as, if you don't know A, then we can write it as A is nothing but the B times sin A over sin B. Okay. So if you know one side and the other two angles, then the other side can be calculated. Okay.
Okay.
Okay. So that we need to be, I mean, immediately that should pop in our mind, like, okay, I can do this, I can do this. Because of this, I am doing this. Because of this, I have to think about cosine rule here, or no, a sine rule will help me. That thought process should be developed. Okay.
Okay.
Okay. Have you studied this cos, the compound angle, or some of the two angles can be written as cos A, cos B?
Cos A cos B plus sin A.
Yeah.
Sorry,
Sin
minus.
A. And similarly, our sin A plus B will look like sin A
Sin A cos B
cos B
plus
add
cos A.
I write it as a sin B cos A. Okay.
Okay.
Okay. I mean, are you interested to derive this? Prove this.
Yes, sir.
Okay, we have a parallel thing here. Negative, we can go for a positive here. Negative, negative here. You know this symbol, right?
Yes. Yes.
Okay, so let's try to do this. I mean, it's not very complicated, but we are going to do it in a geometrical way. Okay.
Okay.
Okay. So what is this? Okay, take a triangle. So I take a triangle. Okay. So I take one angle A. Okay. And I further take another angle. So this will be our B. Okay. So we are questioning about what is this angle A plus B.
Okay.
You get that? So call this as origin O. Then we went first to the A and then extra A plus B. So from here we went to the A plus B. Okay.
Okay.
Right? So
Yeah.
what you do, where you end up, go from there, because this always we can, so go from here to the this one, you just make a right angle here.
Okay.
Okay.
Yes.
So because of that, what has happened, you see, this can be, we know that this can be drawn to make this as a right angle, and we can also draw this will be a right angle. Are you with me?
Yes, sir.
And I am going to draw a line parallel to the base, because I know
Okay.
that this angle is going to be, how much will be this angle?
Which angle?
This one. Okay, so let me draw that. Okay, so let me get a bigger picture. So what I'm saying, you take a baseline with O as a point. So we have a A, and we have a B. Okay,
Okay.
what I'm saying, this will be our A plus B,
Yeah.
and where you end that line, go to the this one to make it as a right angle.
Yeah.
Okay, so now drop a vertical here and drop a vertical here. So this will
Okay.
be altitude will be right angle triangle. Okay, so now I am
Yes.
asking this one, this one. So what will be this angle?
Oh.
So this is a line parallel to the base. Do you get that?
Okay. So it's a line parallel to the base, so it will be A.
Ah, very good. Yeah, do you see that?
Yeah. Okay.
And this is if this is A, and if this whole thing is right angle triangle, and if this is a this will be our 90 minus A, right?
Yeah.
What will be this angle then?
Uh,
This is also 90.
okay.
This is 90. This is 90 minus A. This is A, because of that, because this is also a right angle triangle, right?
Yeah.
So
Then how will that be a triangle?
it will be a triangle. Why not? Okay, let me draw that part. Okay, so we are asking, this is a line. Okay, this is a line, and there is another line here,
Okay.
isn't it? So now
Yeah.
we are saying that there is going to be a triangle here, and we are drawing another line here.
Oh, that is nice. Okay.
Yeah, so this is 90.
Okay. Yeah.
Okay, because that is what is dropped from here to have the 90. So this is our, you said this is our A, this is 90, this is 90. I am asking what will be this angle.
Okay. 1 second. Hmm. This one will be. Yeah. It'll be air.
Ah, you got that, right?
Yeah.
Are you okay with that?
Yes.
Because if you draw a parallel line here also, we know that this is 90 minus A,
Yeah.
and this is 90. Then this angle should be A. Then this angle should be A. This
Yes.
is the same line, and these two are parallel. We get that?
Yes.
Okay. So this is the I'm going to do it again. So if you have a baseline, okay, starting from O, take a and take a B. Okay. So this is angle A, and this is angle B. And when you go from the base, this will be our A plus B, right?
Yes.
So when you are looking for A plus B, when you reach to this line, draw a bit lengthy here. From here, with this line, extend a right angle for this.
Okay.
Okay. Once you have done that, you will have 2 points. So drop them down. Okay. And where you went and drawn the 90 degree, draw a line parallel to the base. That will actually help us. This angle is actually a
A.
because of that this is 90, because of that this will be our A also. Okay,
Yes.
So now we need to name, now we got everything what we need in the geometry. That's it. So call this as a P, this point as a P, this point as a Q, and R, S, and T. Are you with me?
Yes.
Okay. So now we know this is right angle and this is right angle. So we are looking for cos of A plus B. Right?
Yeah.
So why we have made the geometry look like this? Because we want right angle triangle to make our life easy. Because we don't want to
Okay.
bring the cosine rule or sine rule. So for cos A plus B, we will be looking after the triangle because that should be O P R, right?
Yes.
So in the triangle OPR, we can find cos A plus B. That will be equal to,
1 second. OPR.
that is the right angle triangle we have to look at,
Yes.
right? That will
Yes.
have the
Yes.
angle A plus B. So you know the A plus B, so then we can write the,
It,
according to
like,
the cosine definition for the right angle triangle OPR.
okay, it will be cos A cos B minus sin A.
No, you are going for, we are trying to prove that you are not getting the
Okay.
idea. Why we went for a geometry? We already know that in the previous slide
Yeah.
we have
Okay.
written that formula,
Yeah.
right? Because people
Yes.
make us memorize the formula, but we should be good enough to, like we proved the cosine rule and the sine rule. I don't think your teacher has proved that, right?
No. No.
The textbook also won't prove that.
No. No. It's not there.
Because the way of education here makes us like, okay, I told so, the textbook told so, memorize it, solve the problem. They are not increasing our thought process of, okay, why it is so? What can help me to understand from what I already know? Don't you think that we have drawn this geometry with the two angles AB because we are asking the compound, the addition of two angles. So we are making
Yes.
right angle triangles in such a way we can easily write with our simple definition of cosine of an angle in a right angle triangle is, what is the definition?
Is the adjacent side by hypotenuse. Okay.
The A plus B is this angle. Do you get that?
Yeah.
That is actually this triangle, the O to the P to the R.
R. Yes.
That is why I wrote the triangle OPR. So I wrote the cos A plus B. Look at the triangle OPR. Tell me what is cos
Okay.
A
Okay.
plus B.
Yes. 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 Okay. So it's the adjacent side by the hypotenuse. So it's OP by OR.
OP by OR. Okay.
Yeah. Okay.
That's it. So we got the OP by OR. Now all we need to do is look at the OR. OR is actually, look at the OP, the numerator, okay? The OP is nothing but, because we need to bring the other angles, right? The A and B,
Yes.
other triangles. So that can be split into OQ minus,
OP.
no, PQ.
Oh yes. Yes. Okay. OQ minus P.
Yes. We are having the numerator, adjacent side of the triangle OPR for the angle A plus B as a OP. So from here to here.
Yes.
But instead what we did, we went from O to Q and removed the PQ.
Okay.
Okay.
Yes, sir.
Are you okay? So now, so the OQ, now this can be written as OQ by OR minus PQ
PQ
by,
by.
okay. So now we can write this. Look at the OQ. OQ and then
Yes. Yes.
there is a divided by OR. Okay.
Yes.
But if you see the OQ, that is actually going from this point to this point, right?
Yes.
O to the Q. And look
Yes.
at that triangle. Actually, with the angle A, so the OQ is actually the adjacent side for angle A in the
A.
triangle OQS. Do you get that?
Yes. Okay. Yes. Yes.
So this OQ is fine with us, but in the denominator, if you introduce the hypotenuse of that right angle triangle, that is our OS. Are you with me?
Yes, sir.
So as we divided by OS, multiplied by the OS also divided by OR. Do you see this? What we have done? So we introduced this because we want to use so this thing can come from the triangle OQS. Are you with me?
Yes, sir.
In the OQS, we know that already the OQ is in the numerator. So we saw this OQ, then we saw the angle A, and we have seen that if you divide that by OS, this whole thing can be written as a cos A. Are you with me?
Yes, sir.
And as we introduced the extra denominator as a OS, numerator should be multiplied this as OS
With
so that we are
OS.
not changing the value. Okay. So the OR still stay as a OR. Are you with me?
Yes, sir.
Then minus, see the PQ. PQ is also same as the ST,
Yes, TS.
right?
Yes.
T divided by OR. Okay, so this can be written as this OQ divided by OS, OS divided by OR minus, look at the ST. ST in the, so the ST is in the triangle, look at in the triangle RST. This angle is,
Uh, which
right?
angle,
The ST
uncle?
is opposite.
R.
No, look at the ST. You have to be. I mean,
Okay.
I don't know what I am drawing. The ST is the opposite side of the angle A in the triangle RST.
In triangle RST, ST is the opposite. Yes. Yes. Yes.
Okay, but we need to use the opposite side and write the hypotenuse of that right angle triangle. That will be our RS.
Okay. Yes.
And similarly introduce the RS over OR. So we introduced this. Are you okay?
Yes, sir.
So now all we need to do is look at the OQ divided by OS will be cos A, and OS divided by OR will be cos B.
OS by OR. Yes, cos B. Correct. Yeah.
Because this is the right angle triangle.
Minus
We introduce, yeah, minus ST over
S
RS will be,
sin B.
careful, ST over RS.
T over RS.
That is that
Sorry. Sin A. Sin A.
sin A. Now look at RS over OR.
RS and OR.
This
Okay.
triangle.
Yeah. It will be sin B.
Sin B. You have done, right?
Yes.
Are you okay?
Yes, sir.
So we proved that the cos of the compound angle, the sum of A plus B must be cosine A cosine B minus sin A sin B. Okay.
Yes, sir.
Use the same geometry. Look at the sine of A plus B. So tell me what will be the sine of A plus B from the geometry.
One second. I'll just write. Yes. The sine of A plus B. The opposite side of
A plus B. You know where is the A plus B, right? Angle.
Yes, yes, yes.
Yeah.
This
What is that?
RP,
Okay. PR.
yeah, PR by OR.
OR. Okay. Now look at the PR. PR can be split into PT add with TR
Yes,
or whatever it is. RT. I mean anything is okay. Divided by OR. Right.
yes,
It can be written as the PT over
OR.
PT over OR plus RT over OR. So the PT is this segment, right?
Yes,
That is same as the QS. Are you with
yes,
me?
yes,
So this
yes,
can be written as QS over OR plus RT over OR. This can be written as, look at the QS. QS is actually in the right angle triangle OQS, right?
yes,
That will be QS will be opposite side of the sine A. So use the QS, divide by its hypotenuse, that is OS. So OS divided by OR plus RT will be the adjacent side of the, if you see the right angle triangle RST, this one. Okay. RT will be adjacent side of the A. So that will be RT divided by the RS
RS, yeah.
multiplied by RS divided by OR. Okay.
Yes,
So this will become the QS, that will be sine A, and OS divided by OR will be cos OS.
cos of P.
That will be cos of D. This one. You see this big triangle?
Yes,
Yeah. And plus
plus
RT by RS will be RT, that will be cos A, and RS divided by OR will be our sin B.
sin B. Yeah.
So we proved this also. So our sine of A plus B is actually this. Okay. So I draw
Yes,
the
sir.
geometry again. I mean, if you want to prove this, take a base O line, draw two angles. Okay. One as a and another as a B.
Yes.
So we extend this to a level that so we went from A plus B is this angle, the full angle. So we went from the base to this line, right, for A plus B.
Yes.
Isn't it? So what you do, from this, draw a 90 degree to this the line in the intermediate. So this has to be a 90 degree. So once we have done that, we are good. So go down, draw this 90 degree, go down, draw this 90 degree. From here we went down, draw a line parallel to the base. That will make us this as our A and this as our A. Okay.
Yes.
Once we have done that, we start naming them, like you can call that as a P, Q, whatever the R, S, and then this point T. Then we can do the job. Are you okay with this?
Yes, sir.
Okay. No problem, right?
No problem. No problem.
Okay. So now think about our other one, the negative, because we have done the cos A plus B, sin A plus B. We need to do cos A minus B and sin A minus B. Okay. Same thing. You take a baseline, okay, horizontal line to the ground, 0. Take a angle. So we go an angle, say that as a. Okay. This is our
Yes.
A. Okay. And then we go down, that will be our B. So this is our A, and this is our B. Okay. Then this angle will be our A minus B.
Yes.
Okay.
Yes, sir.
So now this is our line for the A minus B. So from the A minus B, draw a right angle to the other line. So this has to be the right angle. Are you with me?
Yes, sir.
The previous case we have drawn it in the other way, like from the top one we went.
Now it's the other way. Yeah.
Yeah, because wherever the A minus B or the A plus, previously this line was our A plus B. That's why from there we went down for a right angle triangle. But now this line is our A minus B. So from here we went to the other one to make it. Then only we can always say that this angle, if you see this angle will be our
90 minus.
no, this is the line.
Which one?
This line is actually parallel to the ground. This line is, the angle is what?
$90 minus A plus B.
A plus B is here, ma. A minus B. Where is the A plus B? Where the A plus B is here?
Okay, sir.
Why you gone to A plus B? Where you find the A plus B here? This whole angle is A.
Oh, whole angle is A. Okay.
Otherwise, how you get the A minus B?
Yeah. Go. Yes.
You are not using the one we are working on, okay? Because you see, you need to develop that. Fully engage with what is we are working on. We are looking for a big angle A and remove a B out of that, then we get A minus B.
Okay.
Do you see that?
Yes, sir.
That is more important. Then you just use the previous geometry. We went to a small angle A. From there further another B. Then we got a bigger angle A plus B.
Okay.
You see the difference?
Yes, sir.
Okay. Now tell me, what is the angle we are looking for?
This will be A.
Engage with the geometry and the problem what we are working on. As usual, drop a perpendicular for this one and perpendicular for this one. Okay, and extend this triangle. Okay, this triangle. So if this is A and if this is 90 degree and this is also 90 degree, this will be 90 minus A, right?
Yes. Yeah.
Because of that, this will be A. Are you with me?
Yes. Yes, sir.
Okay, that's it. We got the geometry we want. Now just to name it, this is a P, Q, R, S, T, for example. Okay.
Yes.
Okay, so this would do. Okay, so now first go for cos A minus B. This would be
Okay, sir. Cos A minus B will be adjacent by hypotenuse. So it will be OQ by OT.
OQ by OT. So how to proceed with this? Remember the similar procedure. Further OQ, see the geometry, the length, whole length OQ can be split into
OQ can be split into OP plus PQ.
Very good. OP plus PQ divided by the same OT, right?
OT. Yes. This
Now,
can be written as OP by OT plus PQ by OT.
now look at where the OP is and which
Yes.
right angle triangle we can use, so that we can use the, so OP should be divided by what? OP already there is a one side of a right angle triangle, right?
Yes, it's called triangle OPR.
So that will be OP divided by what you divide, so that we can use the sine or the cosine. So OP should be divided by, OP is a angle A adjacent side, right?
Yes.
Look for in the right angle triangle, which is the hypotenuse.
OR.
That is what it is. Okay, you are not, don't go to the geometry and look for what is the, look for what we want to achieve. OP is actually a segment which is for the triangle with the angle A, that is the adjacent side. Then complete the triangle, that will be OPR. Then OP is already available. Only if you divide that by hypotenuse of the OPR, that is OR, that will, this ratio OP by OR can be written as a cos A. Do you get that?
Yes.
Because of the new introduction of the OR, the numerator
OR by OT.
OT. Okay. Then in the next one, PQ, that is actually not helping. Go to the very top. That
RS.
is also into RS. RS over OT, time being.
Yes.
Okay. So this can be written as OP divided by OR, OR divided by OT, plus now RS divided by, RS is in that small triangle or RST. The RS is actually the opposite side of the angle A. Do you get
Angle
that?
A. Yes.
Yes. So you need to divide by the hypotenuse. What is the hypotenuse there?
RT.
Okay, RT. So RT. So RT over
RT over OT.
Okay. So now tell me, OP by OR. Look at the geometry. OP by OR will be
OP by OR will be cos A.
cos A. OR by OT.
OR by
This angle is the B.
cos B. Cos B. Cos B.
Cos B. Add with RS by RT.
RS by RT will be sin A.
Sin A. RT by OT.
RT by OT will be sin B.
Okay, we are done, right?
Yes.
So now we have the other job, sine of
Sin
A
A.
minus. Yeah. Tell me, what is sine A minus B?
Sin A minus B will be QT by OT.
QT by OT. Okay, QT by OT. Good. Now QT can be written as
QS minus ST.
QS minus ST.
ST
right?
by OT.
Over OT. Now
That can be written as
yeah,
splitting it.
QS OT minus ST over OT.
OT.
Now this can be written as QS.
Okay.
QS is also equivalent to
RP. Okay. Yeah.
PR, right?
Yes, PR.
PR over OT minus ST. ST is actually in that small triangle.
Yes.
Time being, we can write it as a ST by OT. Okay. As a next
Okay.
step, look at the PR. So the PR is in a right angle triangle. PR over, what is the hypotenuse there?
OR.
OR. Very good. And we introduce the OR in the denominator. Balance it with the introduction in the numerator.
OR by OT.
So in the ST over, ST is in that small triangle RST.
Yes.
T is the
RT.
angle by RT. So numerator also RT over OT.
OT. Yes.
So this will be, so PR, look at the PR by OR.
Will be sine A.
Sine A. Okay, sine A. Then OR by OT.
OR by OT will be sine B.
Are you looking at the
Yes, yes.
triangle? OR by OT, where is that OR? And T is involved. So O,
Oh
R,
no.
and there is a T. This angle is
It
B.
will be cos of, because it will be adjacent. So it will be cos of B.
Okay, careful. Minus ST over RT. That is in the small triangle in that corner.
T by RT will be cos of A.
Cos A. Okay. And then finally the RT over OT.
T by OT will be sine B. Yeah.
Okay, we have proved this also. Okay, so this is our cosine of A minus B, difference of two angle, and this is sine of difference of the two angle AB. Okay. Are you okay?
Yes, sir.
Let me
I just have one doubt.
Yeah.
We say OR by OT is cos B, right?
OR by OT. Yeah, because this angle is a B and this is our right angle. So this is our hypotenuse for that ORT triangle.
Okay, okay. Okay, now I understand. I understood my question.
Yeah. So actually we are dealing with the one right angle, this OQT. Do you get that?
Yes, sir.
This is the one we will be dealing with. Another one will be this right angle triangle, the ORT. That is the
Yes.
B. Okay. And then we will be dealing with the small right angle RST.
Yes.
So if
yes.
you know that we are dealing with this one is the angle A. Yeah, this one is our angle A. This triangle, I mean. You see that this is the OPR is for the angle A. Okay.
Yes.
ORT is for
angle B.
And there is an extra small RST. This is triangle. This is right angle. Another right angle triangle. RST is the small one for again angle A.
Angle A. Okay.
So this is the one will be playing on the two side. This is the one coming from the other one. Okay.
Yes.
Okay. I draw the geometry, because once we get the geometry, all these things we can work out. So first the A plus B geometry. Take a base, draw one angle, draw another angle. Okay. So call this as our A and this as our B. Then totally from base to this one will become A plus B.
A plus B. Yeah.
So where you end that line go down to this line to get the right angle. You see that?
Yes.
Then drop down the right angle here. Then draw a line from here, because this angle will be our A.
Yes. Yeah.
So we will be dealing with, so call it as a O, P, Q, R, S, T, for example.
Yeah.
So we will be dealing with the one. So the O, Q, S. Okay.
Yeah. OQS for angle A.
Yeah, this triangle will be useful, and then the other triangle will be OSR, and another triangle will be RST. Because as this is 90 degree, this is 90 minus A. This is A. This is 90 minus A. This is right angle triangle. This is right angle triangle. This will be
A.
A also. Okay. So this will be useful for our A plus B proof. Okay. Okay. How we got it?
Yes.
So you want me to draw again, or you're okay with this?
No.
Yeah. So now A minus B. So you have a bigger angle to start with as a A, then go down. So come down as a B, so that this will be our A minus B. Okay, so we ended up here. So from here, go and meet this as a right angle triangle.
Yes.
Okay, that is the clue. Then we got the point. So this will be our one right angle, and come down. This will be our another right angle. Now if we draw this angle as this whole thing is a A, this will be our A. Then complete this also. If you want, that will be this is A, this is 90 degree, this will be 90 minus A. As this is 90 degree, this will be our A.
Yes.
Okay, so because of the O, P, Q, R, S, T, now we will be dealing with O, Q, T, O, R, T, and RST. So this one, this right angle triangle, and this right angle triangle. Okay.
Yes.
This 90 degree, this 90 degree, and this 90 degree, and this A, and this A. Now this A is more than enough, and this is our B, and this is our complete A, and this will be our A minus B. Okay.
Yes.
So the thing is, when you go for the A plus B, you go A and then further B. So
Then
A, B, then you will have a
entire
full
thing
line
will be A.
over A plus B. Then if you have this line, then go down as a 90 degree here. From where you end up as a plus B, this is our A plus B line, then go down. Then draw this, then meet this, you will get the job done. But in the case of A minus B, it would be like, okay, draw a bigger A, then come down as a, this is a B, then you end up this line as a minus B. Then from here, go and meet this 90 degree, then complete the, so this will help. Okay.
Yes.
Are you okay?
Yes.
Okay, so the compound angle can come in different problem also, that we need to make use of that whenever we require. Okay. Do you like to see a problem?
Yes, sir.
Okay, 1 second. To look into problems. Okay. Sorry. Okay. Okay, this might be an interesting problem. Let's see how you think about and go about this. Okay, so we are going to solve a problem which looks like mm, 6.5 minus 5 cos x minus 12 sin x. Okay, let me take a snapshot. I put it in the WhatsApp so that
Okay.
yeah, you are here, and then let me take the snapshot. Okay, so this is the problem. Can you?
Yes.
Okay, we send the problem to you. Now, what is that? Yeah, here. Okay, now read me the problem.
6.5 minus 5 cos x
Minus 5 cos x
minus 12 sin x
minus 12 sin x
is equal to 0.
equal to 0 within the range of 0
Where,
less than or
yeah,
equal to x less than or equal to 2 pi.
2
Right?
pi. Yes. Yes.
Now you see this problem is quite interesting. If you see the problem alone, there is a 6.5 is a number, minus 5 is a number multiplied with the cos x,
Yeah.
minus 12 is the number multiplied with the sin x equal to 0. So there is only one unknown, one variable x.
Yes.
But it is appearing in two places, one with a cosine of the x and another with a sin x. So one equation, one variable, the basic rule is this can be completely solved. Okay.
Okay.
But you see that this comes in a bit of a, so what you can think about this? And of course, the sin x and the cosine x, they are periodic functions, so there may be many solutions for the x and x value. Okay.
Okay.
So if you restrict that within a range of 0 to 2 pi, so for only one cycle they are asking us to solve it.
Okay.
So that will come to only one value for the x. Okay. So, and you have a bit of a clue that just now we proved the cosine compound, sine compound angles, and then the difference of the angles.
Yes.
So how you proceed? Well, I want to know your thought process. Can you think about in what way? Don't rush.
Okay.
Like we have x at two different places in the equation, one with the cosine and one with the sine, right?
Yes.
And in front of the cosine x there is a 5, in front of the sine x there is a 12, and there is a separate number 6.5. Any idea? Can you think something so that first of all we have to make the x to become 1, because appearing in two different places is not helping us. Do you see that?
Yeah.
Even if you divide the whole equation with a cosine, the 6.5 divided by cosine will give you a secant.
Yeah.
That we don't want, because that will be again it will be appearing in two places. So any idea? So first thing I will also simplify this to write it as a 5 cos x plus 12 sin x is actually equal to 6.5 can be a 13 by 2, right?
Yes.
Okay. So this is now, with this can you get a clue? Do you see in front of the cos x there is a 5 multiplied?
Yeah.
And in front of the sin x there is a 12 multiplied.
Yes,
Is
12.
So the 512, let's say if we can convert this 5 numerical value into a some new sine alpha angle or something like that. And if this 12 also to become a cosine alpha, for example,
Okay.
then this whole thing will look like cos alpha cos x, this is sin alpha cos x, cos alpha sin x. Then we can put all of them together as a
Yeah, we can put it as sine, like
sin
sine A
alpha
minus.
plus sin alpha plus x. Do you get that?
Yes, yes,
But definitely the alpha should be connected to the numbers 5 and 12. Do you get that?
yes.
So this is how we need to develop our thought process, okay?
Okay.
And also, as it is related to the number 5 and 12, then definitely we will know the alpha value, then the problem will be solved. And also
Yes.
we know that the sine, any sine theta has to be within the range of, it cannot be, it should be less than or equal to plus or minus 1, right?
Yeah.
And the same with the cosine theta also. We cannot have more than this value. But the 5 and
Yeah.
12 was humongous. Do you get that? Compared to the 1.
Yeah.
So, and also we only one number, we cannot write it as a sine form. We need to have it as a ratio, some opposite side by, then only we
Yes.
will have a angle for that, right?
Yeah.
So this 5 is
Can we
related to
multiply it?
no, let's put it this way. Like, let's call this is our opposite side of the alpha, and this is our adjacent side of the alpha. That is our triangle, right? So take a
Okay.
right angle triangle for the alpha alone. Okay, call this as our alpha. Then according to what we want, this could be our 5 and this could be our 12, right?
12. Yeah.
Then how much
That
is
will
this?
be 13. 13.
Yeah, square root of 5 square plus 12 square,
Yes.
right? That comes
Yes.
to
169. So which is root of 169.
so that is square root of 5 square plus 12 square. Do you see how I proceed with this? And
Yes. Yes.
So this is the smartness we need to develop. We need to allow the problem to help us to proceed with this. So
Okay.
this actually helps us. We can have a sine alpha is actually opposite side by hypotenuse, and cosine alpha is going to be our 12 over 13, right?
Yes.
So take this equation, divide by 13. Actually, there is a clue here also that 13 comes, so that will look like 5 over 13 cos x plus 12 over 13 sin x will be equal to half. Are you with me?
Yes.
So now this can be written as our sin alpha cos x plus 12 over 13 can be written as a cosine alpha sin x equals half.
Okay.
Right. So now
Yes.
this can be combined as a sine of alpha plus
Sine
x,
of alpha plus x.
which is equal to 12. Now you see we introduce a new angle. Also we can we know that, I mean, this can be always alpha is actually sine inverse of 5 over 13. Same, I mean, it can be also cos inverse of. You can use the calculator, but it should be in the radian. Okay, we have to be careful with that. 12 over 13. Okay. So now alpha plus x is actually sine inverse of half. Okay.
Yes.
That will be pi by, because when they are given a range in the radian, we need to solve everything in the radian.
In radians. Okay.
So this will be equal to, actually sine inverse of half is sine 30 degree, right? 30 degree.
Yeah. Yes.
5 over 5
Pi
over
by
6.
6.
Right?
Yes.
Okay, 5 by 6. So we solved it. So finally this tells us this is alpha by alpha add with the x. So this is actually giving an answer. X is nothing but 5/6 minus alpha.
Yes.
So now you need to find the alpha using a calculator for this ratio, but both of them you should satisfy. That will be only one value. So subtract that value from 5/6. That will be your x.
Okay.
And once you got the final answer, you can go back to your problem. There you need to substitute the value for the x and check whether the equation satisfies the final answer. You will have only one answer for that. If you want to have you can do it on your own. I will tell you the final answer. Oh, actually I got two answers, 0.126 and 2.22. There are two values which can satisfy this. Okay, I will write it as 0.126. So x is 0.126 radian and another value is 2.22. Okay. So because it is in the 2.22 radian, because it is x is to be from 0 to 2 pi, both the sign has to be, so it would be in the, there are two values which is satisfying this. Okay, try to check it whether you can get the answer. Both this value will satisfy.
Yes.
Do you understand how we proceed and how we solve the problem? Give a try yourself and get confidence in developing that. Okay. If you have any problem in solving this, message me. Otherwise, we will meet next Sunday. Okay.
Okay.
In the next 4 months, we will have this new time. Like. Okay. So the end of 5 months. End of March, they will change back to the summer time. Okay.
Okay.
Okay, Ishmael. Take care. Okay.
Yeah. Okay.
Bye now.
Thank you. Bye.